All right, so we're going to finish up this week with parallel lines in the coordinate plane. So we'll talk about the slope of a line, the y-intercept, what makes lines parallel, things like that. Okay, so from algebra, we've talked about slope before. And how do you find slope? There's usually like two words that we use to describe it. It's something over something. Yeah, Katrina? Yeah, it's the rise over run. It's the ratio of rise to run. And that only works if it's a non-vertical line. Okay, because if you had a vertical line, let's say something like this, and you wanted to find the slope of it, well, there's definitely a rise here, but what would be the run between those 2 points? How far left and right would you go to get from one point to the next? How much? Zero, yeah. So there's no run. Well, the problem is if the run is 0, and the formula to calculate slope is rise over run, you'd be dividing by 0. Okay, we can't do that. So a vertical line is kind of a special case. Anybody remember what we call the slope of a vertical line? Yeah? It's undefined. Okay, but for any line other than vertical, the slope is a number. So rise basically is the vertical change between 2 points. And run, that's the horizontal change between 2 points. Okay, and I think I have a picture of it later on, but let's say you had 2 points. The dotted distance, you know what? Let me do it in red. The dotted distance in red, that's the rise. Okay. The distance that's horizontal in black, that's the run. Okay. And you can measure those two distances sometimes if we had like sometimes we'll be given a ramp, and we can find the height of the ramp and the length of the ramp, and we can find the slope of it. Or sometimes you'll be given coordinates, and we'll talk about how you find the slope with coordinates as well. Okay. Anybody remember how you do it that way? If you've got coordinates x1 and y1, your first x and first y value, and then x2 and y2. What's the formula for slope using your x1s, y1s, and all that? Kier?
N equals y2 minus y1 divided by x2 minus x4.
Yep, exactly. So there's your formula for slope using coordinates. y2 minus y1 goes in the top. x2 minus x1 goes in the bottom. You can't flip that. If you flip it, then it's wrong. So my suggestion to try to remember that, okay, it kind of rhymes. Rise goes with the y's. Rise, y's. Okay, so rise is in the top. Y's are in the top.
Oh, run.
Then you have run and x, which doesn't matter. Okay, but y's goes with rise. Okay, and here's the same picture I just drew showing rise and run with two coordinates. Okay, everything that we do in this section is going to be about the slope of a line. Okay? If you measure the slope of a line, say between this point and this point, or you use this point and this point, are the slopes going to come out the same or different? Same. Okay, a line has the same slope all the way. What doesn't have the same slope all the way would be a curve, a parabola. Okay, that's one example. Okay. Parts of it have a very steep negative slope, okay, over here. Then over here, parts of it have a really steep positive slope. And then at the very bottom, the slope is actually flat. It's 0. Okay, in geometry and probably even algebra 2, you don't get into finding slopes of things that are curved. Okay? that gets into calculus, finding the slope of a curve, because it keeps changing all the time. All right, so we'll be sticking with lines. Okay, I think Kiara had said this earlier. I hadn't said it yet, but slope is usually represented by the variable or letter m. Okay, so there's an equation we'll talk about in a little bit that has an m in it. It also has a b in it, and we'll just make sure we remember what the m and the b are. Okay, but this is the m. M is slope. Right, so let's take a look at our first example. Okay, this one is about the cog railway that goes up the side of Mount Washington. Has anyone ever been on that? Cog railway? It's really pretty cool. If you have a chance, it's an extremely steep train ride. Okay, it's it's pretty expensive. It's kind of, I think it's like $60-something round trip, but it is pretty neat to go on it and look out the window. And I mean, you're like this steep, and you're looking out at everything else, and it's pretty cool if you get a chance to try it. And if you just want to go one way, if you could take the train to the top, and then you could hike, walk down. Then it's a little cheaper one way. It's like $40-something. But it's around there. But it's pretty neat. So this is about the cog railway. Okay, it goes up the side of Mount Washington, and it says at the steepest section, the train goes up 4 feet for every 10 feet it goes forward. Okay, it goes up 4 feet for every 10 feet it goes forward. Let's find the slope of that section of the railway. Okay, so what is the 4 feet? In terms of the words we've been using to describe slope. It says it goes up 4 feet. Brian? This is your rise. And then it says it goes forward 10 feet. 10 feet is like my, what? Yeah? That's my run. Okay? So we've got rise, we've got run. All we have to do is divide them. Okay, which one goes in the top? Rise or run? Yep, Sarah? Rise goes in the top. Slope equals rise over run. Rise is 4. Run is 10. We usually reduce the slope as much as you can. What is 4/5 reduced to? I'm sorry, what is 4/10 reduced to? I gave you part of the answer. Yeah, 2/5. All right. Okay, so the slope is 2/5. That's pretty steep. Okay, in terms of a road, like if you talk about it, look at when you're driving, sometimes they say the grade. Anyone ever seen those signs that say, steep grade ahead on the road? Well, grade is a measure of steepness. This would be a 40% grade.
That's steep.
That's very steep. That's like almost halfway between being vertical and horizontal. That's a very, very steep road. You wouldn't see any roads out here with that kind of grade. We've got, heading down the hill towards Leominster, there's some roads that are like 7%, I think after the Merriam Ave exit. But I'm trying to think if there's anything else. Out west, I know they've got some roads that may be 12% grade, 13% grade, about 40. No way. That's a really steep road. Maybe a mountain road. Okay, but even that, I mean, you'd need a heavy-duty four-wheel drive to go up something like that.
I saw when they were building Route 66, they had this road. People had to go over backwards because the car would stall because it wouldn't get gas to the engine.
Oh, because it was so steep?
Yeah.
Yeah.
Because the gas pump.
Yeah. Wow. So that's really, really steep. All right. Any questions on how we found the slope of that? All right. Okay, let's try one where we have coordinates. Okay, so they're not giving us a rise and a run. We have to find the rise and the run first. Okay, so let's start with the point 0, 6. What could we call the 0? In terms, could it be x1, could it be x2, could it be y1, or y2? We do have a couple options here of what it could be. Yep? Yeah, it could be x1. It could have also been x2. Okay? But now that she picked 0 as x1, what does that make the 6? Now we don't have a choice. That makes it y1. And now that automatically makes the 5 x2. And it makes the 2 y2. All right. I like to label these first so that way I can just fill them into my formula. So slope. What goes in the top? You don't have to give me the numbers yet. Just tell me, is it x1? You know, what goes in the top? y2 minus y1. And the bottom is x2 minus x1. Okay, so just fill them in. The biggest mistake I usually see is either people flip that, which you don't want to do, or when there's negatives for coordinates, they get confused when they start subtracting a negative. Okay, so just be careful with the arithmetic. So y2 is 2, y1 is 6, x2 is 5, x1 is 0. Okay, 2 take away 6. Luke, what does that give me? Negative 4 divided by 5 take away 0 is just 5. What does a negative slope mean? Versus the one we just did was a positive slope. Yep. Yeah, it means as you head to the right, it's heading down. Versus as you head to the right, if it's heading up, that's a positive slope. All right. When we talk about like the grade of a road, though, they never use a negative percentage. Okay, they just use a positive percent. 5% grade, 12% grade. What's that? Yeah, they always view it as going a positive way. Positive, yeah. But, yeah. Okay, and where the slope can come in handy, it can help us determine if lines are parallel. How can we use the slope to determine if lines are parallel? Denver? Yeah, if they have the same slope. Okay, so this is the slopes of parallel lines postulate, so we're not going to have to prove it. And I'm going to add to this a little bit, but this is what the book has. It says, in a coordinate plane, two non-vertical lines are parallel if they have the same slope. Okay, the reason they say non-vertical is because generally when we're talking about slope, we have a number. But if the lines are vertical, the slopes are undefined. So that's kind of a special case. Any two vertical lines are automatically parallel. Anybody think of something that you might want to add here? I wanted to put it the way the book does it. In a coordinate plane, two non-vertical lines are parallel if they have the same slope. That is true, but I think there's something, I would say there's something missing. Denver?
Can't have the same y-intercept.
Right. What happens if they have the same slope and same y-intercept? Yep.
They intersect.
They do. They intersect everywhere, and that means that they are one line. They're the same line. I would argue that two lines that are right on top of each other are not parallel. They're the same line. Okay? So I'm going to add, so in a coordinate plane, two non-vertical lines are parallel if they have the same slope and different y-intercepts. Okay, maybe the book didn't mention that because they didn't mention a y-intercept yet, what that is. But from Algebra 1, we know what it is. So I think we should add that in. Okay, we already went over this fact. A vertical line has an undefined slope. How about the line that's perpendicular to vertical, horizontal? What kind of slope does a horizontal line have? Well, there is a slope. There is a number for it.
0 slope.
0, yeah. So it's the number that represents that, 0. Okay, any question on the slopes of parallel lines postulate or the statement that I added in? All right. So, the question on this one says, is J1 parallel to J2? Okay, and my picture might not be perfect. It might not be drawn exactly to scale, but these coordinates are. That's 1 point, and that's another point on J1. And now we've got 2 points on J2. This one and this one. Okay, because we have a grid this time, we don't have to use the formula y2 minus y1 over x2 minus x1. We can just count rise over run. Right? Now, if we didn't have a grid and they gave us coordinates, that's what we just did before. So let me make it bigger so people can kind of see that. It's a little hard to see. What's the rise between the red points? How far up do you have to go to get from one to the other? Luke?
Between the 2 red points?
Yeah.
So before 4 over 2?
Yep, you go up 4 and right 2. Okay, when I'm doing slope, okay, first thing I like to do is just look at the line and figure out, okay, it's in the positive direction. So if you go up and to the right, that's a positive slope. If you went up and to the left, that would have been a negative slope. Right? But hopefully everyone remembers that from Algebra 1. Okay. So you're going to go up 4 and right 2. So let's figure out the slope of J1. So it's 4 divided by 2. This gives me a slope of 2. Right, now let's do the slope of J2. Okay, what's the slope of J2? What's the rise? What's the run? Alyssa?
2 over 1.
One more time?
2 over 1.
Yep, it's 2. Up 2, right 1. Has a slope of 2. So are those lines parallel? Yes. Okay, yes, they are. So, whoops. Is J1 parallel to J2? Yes. Now, if you look at my picture, it doesn't. It might not necessarily look parallel. Okay, it might. Maybe to me a little bit. It looks like they're getting a little closer together towards the bottom. Okay, a little bit more spread out at the top. All right, but that's just because of the way I drew it. Okay, the coordinates are indicating they are parallel. All right, next part. We're going to look at how we can write the equation of a line. Okay, first thing we got to do is remember the formula for it. Okay, we're going to use the slope-intercept form. Okay, you might have used point slope. That's one way to do it. You might have used standard form. That's another way. But we're going to stick with slope-intercept. Anybody remember the equation of a line in slope-intercept form? Selena? Yep. Y equals mx plus b. Very good. Okay, and the m and the b both stand for something. Okay, anybody remember what one of those letters stands for? Ian?
B is the y-intercept.
Yep, b is the y-intercept. And what about m? We just find?
Slope.
That's your slope. Okay, so we know what slope is. Slope measures the steepness of a line. Okay, don't get it confused with an angle. Slope's not an angle. Okay? The steepness that something is at might create an angle, which say the ground or like a ramp or something like that. But slope itself is not an angle. It's a ratio of rise over run. But what about y-intercept? We haven't talked a lot about that. What's a y-intercept? What is it? But what does it mean graphically? Like if you were to draw it, what does that mean? Yep. Would say we only had one line though. If we didn't have two, if you just draw one line. Point, she's close. The point where it crosses the y-axis, yeah. Okay. Is there any kind of line you could have that might not cross the y-axis? Most lines do. But is it possible that you have a line that doesn't? And what kind of line would it have to be? Yep. Yes, a vertical line. Okay, if you draw in a vertical line, it might not cross the y-axis. Any other line always will. One more question about intercepts. What kind of line, what point would a line have to go through so the x and the y-intercept are the same value? When would that happen? It crosses the x-axis and the y-axis in the same spot. And there's a name for that spot. The origin. If you have a line that goes right through the origin, okay, that's going to be where your x and y-intercept are the same. That's the only place they're the same. Okay, for a vertical line, that's a little bit of a special case. We can't write it as y equals mx plus b form. It has to be written as x equals a number. So if you wanted to draw a vertical line at 3, the equation would be x equals 3. If you wanted a vertical line at negative 2.6, it would be x equals negative 2.6. Okay, so that's a special case. How about a horizontal line? Does anybody remember from algebra? What's the equation of just a horizontal line? And if you look at y equals mx plus b, and you remember what the slope of a horizontal line is, that would help too. Remember that? Yep.
Isn't it just y equals a number?
Yep, it's just y equals a number. Because what's going to happen there is the slope is 0, and then this whole part disappears. Because you'd have slope of 0 times anything is 0. So it would just be y equals a number. And that number would be your intercept. Right? All right. So now what I want to do is write an equation of a line. I want it to pass through the point 2, 3. And I want it to have a slope of 5. Okay, so definitely kind of problem you did in Algebra 1. You're given a point, you're given a slope. Okay, what we need, though, is we need b. If you want to write the equation of a line, the two things you really need are m and b. But using the coordinate they gave me, I can find b. All right? And once we find b, then we can write our final answer. Y equals mx plus b. Just fill in the m and the b. Okay, so what I like to do is usually make a table, okay, to organize everything I know. Okay, in the equation y equals mx plus b, there's 4 letters. There's y, x, m, b. They've given me 3 out of 4 of those letters in this problem. Okay, what's the 2? Which letter is that? Look at that, Dakota. That's an x value. Yep. How about the 3? That's the 3. Yep, that's a y value. And somebody else, what's the 5 in this case? Selena? That's m. Okay, so we have x, y, and m. So let's make a table. All the table is for is organizing our information. So x is 2, y is 3, and the slope is 5. What's the only letter that we're missing? Anthony? B. Yeah, we just need to find B. All you got to do is fill in those 3 letters in the right spots, and then you can find out what B is. Okay, so y is 3, m is 5, x is 2. And now solve for B. Okay, Rose, what's my first step to solve that equation for B?
Multiply 5 and 2.
Sure, multiply 5 times 2. And now my last step. Okay, Marquise, what's my last step to get B by itself?
-10.
Good. -10, -10. And 3 take away 10 gives me, Justin? -7. Good. All right. So now I've got B. I've got M. Can anybody give me my final answer to that problem? And remember, it's going to start out y equals, and just fill in the 2 things I circled. Luke?
Y equals 5, 2 plus 6. Oh, plus -7.
So let's go back and look at it. So write your final answer filling in M and B only. Yeah.
Y equals 5x minus 7.
Yes. So your final answer should have an X and a Y in it. And that's perfect. Okay, so that's the equation of the line that would have a slope of 5, and it would go right through the point 2, 3. In fact, it's the only line that has a slope of 5 and goes through the point 2, 3. Okay, any questions on that? Okay, so you'll have a couple of those on the test, and probably one like this. Okay, we have 2 lines, N1 and N2. Line N1 has this equation, -1/3 x minus 1. Line N2 is parallel to that one and passes through the point 3, 2. I want to know the equation for line N2. Any thoughts on how would we start that? All we know about line N2 is that it's parallel to line N1, and it has to go through the point 3, 2.
Does N1 go through the point 3?
No, N2. N2 is parallel to N1, and N2 passes through the point 3, 2. Denver?
Same slope.
All right, so what's going to be the slope of line N2?
-1/3.
Okay, so the slope of line N2 is -1/3. How do we know that? It's parallel to line N1, so it has the same slope. So we know the slope, and we've got a point, so we can figure out the equation. All right, so try that one on your own. Make your table, organize your data, solve for B, and see if you can find the equation for line N2. Okay, let's make our table. Since line N2 is parallel to N1, what's the slope of line N2? Yep, -1/3. Okay, what's the point that I want line N2 to pass through? 3, 2. And 3 is the 3 is the x, 2 is the y. Okay, fill all of that in. to y equals mx plus b. 2 equals negative 1/3. I'm going to make x into a fraction because I'm multiplying it by a fraction. So just put it over 1 plus b. Okay, what happens with the 3's there? Yeah, they reduce. So all I'm getting is negative 1 over 1. I just get negative 1. Add 1 to each side, and how much is b? 3. So I've got b, got m. So what's going to be my final answer? Selena? Plus 3. Yep. So there's the equation of my line. All right, so for tonight, okay, the homework's on page 168. I'd like you to do 5 to 21, just the odds. 25, and then 29 to 43, just the odds. Okay, for the MCAS questions, do the open response. And I think there's only one, so just do the first open response.